Hi, we're back, and we're going to talk about a scientist named Ernest Rutherford. So we just left off with J.J. Thomson and his plum pudding model, and we're going to talk about a scientist named Ernest Rutherford. He actually worked as a student under J.J. Thomson. So he was a physics student working in J.J. Thomson's lab, and what he did research with was basically a bunch of nuclear physics, nuclear chemistry. Dealing with something called an alpha particle. We won't get into those until the end of the year. And he did this famous gold foil experiment. And the gold foil experiment he gets credited with, but in reality, he actually he had some students that he had working in the lab that did the experiment for him. And those students a lot of times don't get as much credit as they should. They ended up being very famous physicists as well. So what was Rutherford's experiment? So what he was doing is he was trying to figure out when you shoot this beam of alpha particles, it's something that's very destructive to tissues. They were just studying nuclear physics. So he had some kind of radioactive source here, basically shooting out radiation, and one of those things is called an alpha particle, we know now. And so this radiation would kind of get shot out of this box here and go and he'd shoot it at a very thin piece of gold film. And what he noticed is that, like, when it would go through the gold film, he had a phosphorescent screen here, where what would happen is as these particles hit it, it would light up. So these little particles would make little kind of spots light up on the film, so you can determine where the particles are hitting. So he would do this experiment, and he would notice that some of them would get deflected a little bit, and so he was doing some research on how they got deflected. As a professor, one day he was upset with his students. I think Geiger and Marsden were their names, and what he told them to go do was to take the little backing here where these particles got deflected and flip it around and have it go on the back side over here. And he just thought that what he was going to do is because the students had to sit in a dark room and watch and look for kind of these little specks of light to pop up. So he just thought he was sending his students in there just to kind of be mean and punish them. I just want you to go sit in a dark room all by yourself for hours and hours and hours. And what ended up happening was the students came back and they were all excited and saying, hey, we actually saw some things. We wouldn't have expected that. You're so smart. And so he kind of got credit for this. But in reality, he did it just because he was trying to waste some grad students' time. So what kind of came from this? And by the way, he won a Nobel Prize for this experiment. Well, according to J.J. Thomson's plum pudding model, these alpha particles should go straight through the atom. But what he found out is that every once in a while, one would get deflected, and every once in a while, even a smaller chance, some bounced back. And so what ended up happening is he kind of made a model of an atom where there's this little center in it that he called a nucleus. So he basically came up with this new model called the planetary model of the atom, saying that the atom is actually mostly empty space, where you have a very small nucleus that has all the mass packed in, and then you have the electrons orbiting around that. And so this is kind of the model of the atom here that I'm showing you that Rutherford was able to come up with. But what he was actually able to do, it was more precise than just saying, hey, there's something hard in the middle. He was actually able to, with his experiment, find out how many particles went through and how many particles bounced back, and do some calculations on how big he actually thought that a gold nucleus was. And he was actually very, very close with some of his calculations, figuring out how many particles went through and how many would bounce back. So he was able to figure out kind of what percentage of the atom was empty space, what percentage was the nucleus, and it's incredibly tiny. If the nucleus was like a little marble-sized thing, I would have to go to a football field, and the electrons would still be going outside of where the football field is. So I mean, in terms of the size, it's an incredibly small little nucleus with all these electrons taking up all the space around it. So that's where Rutherford got us with this planetary model. Classic physics had a lot of problems with this model, and so a lot of scientists were on this right away. This model didn't stand for very long.